Hello again. So this will be objective 2 for complex numbers. So this objective here is operations with complex numbers. Operations just meaning different mathematical skills that we know how to do. So this would just be kind of like a menagerie of different things. So we can apply operations of real numbers to complex numbers. The first one we'll do is called the additive inverse. My computer is really freezing up. Hopefully it figures out. I think I'm running the RAM here really hard. Okay, so the first operation is called the additive inverse. So what this is basically you want to find the sum of two you want to make two complex numbers equal 0. So for an example, find the additive inverse of -2 plus 5i. So I want to find a complex number here that would make this complex number, when added together, I would get 0. So I'd do plus some number a plus some number bi equals 0. This is what we're trying to find. So if I have -2 here, if I add 2 to it, that cancels out the a part. So a is going to be 2. And if I have 5i, if I add a -5i, or just minus 5i, I get 0. So -2 plus 5i, just combining like terms here, -2 plus 2 is 0. 5i minus 5i is 0. So the additive inverse of -2 plus 5i is 2 minus 5i. So really you're just taking the signs here and you're switching them. Okay, another example here. Find the AI, so the additive inverse of -5i. Okay, well, -5i plus 5i equals 0. So your answer is 5i. Really simple. I'll do one more example. Find the AI, so find the AI of 4 minus 3i. Alright, well, 4 minus 4, that gets rid of the a. -3 plus 3i, that gets rid of the -3i. So the additive inverse would be -4 plus 3i. Alright, done with that one. Adding and subtracting complex numbers. So we already really did this here. When you, to simplify the expression, when you add or subtract complex numbers, it works just like normal numbers. Combine like terms. Okay. So I have this here. I'm going to add these so I can get rid of these parentheses here. So this becomes 5 plus 7i minus 2 plus 6i. Well, we're going to combine like terms. 5 minus 2 is 3. And then 7i plus 6i is 13i. Just like that. I'm really only just going to do the one example on this one. It's just combining like terms. Alright, multiplying complex numbers. Okay, so this involves a new thing here. So remember that I is equal to the square root of -1. Well, I squared is like saying the square root of -1 times the square root of -1. Well, the square roots get rid of each other, right? So that gives me -1. Interestingly enough, I cubed is equal to root -1 times root -1 times root -1. Well, I squared is -1, so I can write this as -1 times the square root of -1, which becomes -1 times I, which equals -I. And then I to the 4th power is I squared times I squared, which is -1 times -1, which equals 1. So that's kind of cool. I to the 4th equals 1. I to the 5th would be 1 times I, so you're back at I. I to the 6th would be -1. I to the 7th power would be -I. I to the 8th would be 1. It goes in a big cycle like that. Alright, so multiplying complex numbers. So let's do our first example here. 5i times -4i. Okay, so just like with normal numbers, the constants multiply, so I get -20. And then these i's are going to combine, so I get -20i squared. And we said that I squared is -1. So this turns into -20 times -1, which equals 20. Not bad. Alright, another example here. Now we're going to take two complete complex numbers, so 2 plus 3i times -3 plus 5i. Alright, so let's go ahead and do this. We're going to FOIL it. So first would be -6. Outer would be 10i. Inner would be -9i. And then last would be 15i squared. This is going to be -6 plus I, and I'll just do 15i squared. I squared is -1, so this will be 15 times -1, so that's -15. -6 minus 15 is -21, and then plus the I. So there you go. Do one more example. 4 minus 9i times 4 plus 3i. So we'll do the first, that's 16. The outers will be 12i. Inners will be minus 36i. The last will be minus 27i squared. This is going to equal 16 minus 24i plus 27. Right, because that's -27 times -1, so that's plus 27. This is going to be 16 plus 27, so 43 minus 24i. Notice that the product of two complex numbers is a complex number. And the product of two complex numbers with the a plus bi. The product of two complex numbers with just the imaginary part is a real number. So two imaginary numbers multiplied together gives you a real number. I'm going to stop for there. We have one more portion of this called finding complex solutions, and we'll cover that tomorrow. Thanks for watching. Bye.